Hey guys, Mr. Backwork here. In this video, we're going to look at simple harmonic motion. So when we're talking about simple harmonic motion, we can think about that motion as like a weight bobbing up and down on the end of a spring, where it's just constantly bouncing up and down, hitting a maximum point, and then dropping back down and hitting a minimum, and then coming back up and hitting that maximum again, where it has that kind of sine wave or cosine wave look to things. So in this example, we're going to look at the motion of a weight on a spring. So we've got a weight hanging from a spring, as shown in the diagram down below. It's stretched 5 units beyond its rest position. So in this equation, we're going to use S to represent the position of our weight. So at an S value of 0, so kind of right here, that middle equilibrium between the maximum point and the minimum point. So it's released at a time of 0, and it bobs up and down on this spring. Its position at any time, t, can be modeled with the equation S equals 5 cosine of t. And what we want to do is use this position function to help us determine its velocity and acceleration at any time t. So if we're talking about velocity first, velocity, I'm going to call this v, is the derivative, the first derivative of that position function. So we're looking at differentiating this S equals 5 cosine of t to give us our velocity function. So if we do that, the 5 stays as a constant multiplier on there. And then if we differentiate the cosine, if we find the derivative of the cosine, that's going to turn into negative sine of t. Now if I multiply this 5 back in there, then we could really call it negative 5 sine of t. So that's our velocity function. Now if we want to find the acceleration is the derivative of the velocity function, or it's the second derivative of that position function. So we're going to differentiate this negative 5 sine of t that we just got. So we've got that negative 5 multiplier, so it stays as a multiplier in the front. And then if we do the derivative of the sine of t, well, the derivative of sine is cosine of t. So my acceleration function is this negative 5 cosine of t. That's going to be it for this video. Thanks for watching.